The figure shows a system of two concentric spheres of radii R1 and R2 are kept at temperatures T1 and T2 respectively. The radial rate of flow of heat in a substance between the two concentric spheres is proportional to, right? Now this question came in 2005. Although, question like this you might have done in your theory, it's given in your booklet also, in fact, Design Tutorials booklet. So if you have done this in theory, you might have derived the formula, right, for heat flow. But if you have not, then what you have to do is in the question paper itself, you have to derive it. So what I'll be doing is, rather than giving you the direct formula, let's derive it. Let's see how to calculate this kind of a question. Let us suppose that this is R1 and the inner thing is the temperature T1, right? Now this is R2 basically, right? This is outside, this is R2, and this is at temperature T2. Now let us assume, because see what is happening is, if I move from here to here, what is happening? The area, if let us suppose I am at this point, this has a different area, and if I go outside more, then that will have a different area. That means the resistance is variable. The resistance is variable, right? So what we do is, let us assume at a distance x, a dx thickness element, right? A dx thickness element, right? So, and across this dx thickness elements, we have the temperature change, let us assume as dt, right? Like it is going from this surface to the outer surface, covering this dx thickness. Let us assume that the temperature change becomes dt. Now heat flow is constant, that means dq by dt I can write it as h. This is constant, right? Now this will be equal to what? What is the formula? The formula is Ka delta T upon x, where x is the distance traveled. So if I'm going from this point to this point, or rather from this point to this point, what is the distance that I've traveled? I've traveled dx thickness, that means K. What is the area? Let us assume that the area is constant for this, that means 4 pi x square, right, divided by dx, this is the length, and what is the change in temperature? Delta T, this is dt, right, and this h is constant. So what I have to do, I have to integrate it, right? So what I'll do is, I'll take this dx over here and all the terms of x over there on the left side. That means h into dx over x square, this will be equal to what? K into 4 pi into dt. Now I will be integrating it from what? T1 to T2, right? And x is from R1 to R2. So what will be the integration? It will be h into dx over x square is given by minus 1 upon x. That means minus 1 upon x and its limits from R1 to R2, right? This will be equal to 4 pi k into dt. That means t and its limits from T1 to T2, right? So that means I can write it as h into, now there is a minus, so that means 1 upon R1 minus 1 upon R2, right? I have taken this negative into account. This will be equal to k into 4 pi into T2 minus T1, right? So I can write h as, h will be equal to what? 4 pi k T2 minus T1 into R1 R2 divided by of R2 minus R1. Obviously if I'll take over there, that means the correct answer, what is it is asking? It is asking the radial rate of flow of heat, that means dq by dt in a substance is proportional to R1 R2 divided by R2 minus R1. That means D option is correct.